want to do is just show you some examples that relate to side-side-side similarity for triangles. So looking at example 1, we want to determine whether or not the triangles are similar. So we have triangle CAT and triangle DOG. So what we want to look at here is the ratios of the sides. So if I were to take the smallest side in this triangle, which is 3, and the smallest side in this triangle, which is 9, I can see that the ratio of those sides is 3 to 9, which equals 1/3. Okay? Now, if I take the next set of sides, if I take the medium side of this triangle with the medium side length of this triangle, I'm doing 4.5 divided by 13.5, and when you divide that, it also reduces to 1/3. And these are things you can do on your calculator. It may give you 0.3 repeating, but you should be able to see that those decimals are exactly the same. Okay, so whether or not you're looking at decimal or the fraction, it works either way, okay? And then we have to take the last set of sides, which is the largest side, to the largest side. So if I do 6.1 is to 18.3, and I divide those in my calculator, I can see that it's also going to reduce to 1/3 or 0.3 repeating. So once we see that the ratios of the sides are all the same, we can finish our similarity statement, which would be triangle. And if I trace the triangle from small, medium, large, I would say triangle TAC is similar to triangle, and I'm going to go small, medium, large, O to G to D. Okay, example 1. Okay, so example 2 here, what we have is a diagram that has 2 triangles connected. Now, what you should notice is that there are 2 side lengths that each have a side of 5 here and here. Okay, and we got another set of side lengths that have 7 and 7. So what we're looking for now is the 3rd side. Now, if we drew those triangles separately, okay, if I were to take triangle OME and, oh, not E, sorry, OMH, and triangle, let's see, so if I do OM is 7, OH was 5, okay, and now I'm going to take a look at the next triangle. So I want the next triangle base to have a side length of 5, okay, and I want this side to be 7. So we can see where the 5 and the 7 are both connecting here at the E, and this side over here with the other 5 would be the M. So this one is the H. Okay, so if I draw them separately, I can see this side length here is the one I'm looking at, where MH and HM actually line up together. Now, we don't know what that length is necessarily, but what we do know is that it is the same as this one, because in the diagram it is a shared side length. So it doesn't matter what it is numerically, we know that it is going to be the same in both triangles, so therefore we can say that the triangles are similar. So when we are writing out the similarity statement, and I've already drawn the triangle separately so I can see how everything lines up. I'm going to say triangle OMH is similar to triangle EHM by side, side, side similarity. Now, if you notice, the ratios for these sides are actually 1 to 1, because if I do 7 is to 7 as 5 is to 5, they both equal 1. And if we know that the ratios of the sides are 1, therefore we also know that the triangles are congruent. There's our symbol for congruence. And if you notice that symbol right there, that congruent symbol has an equal sign and it has a similar symbol as well, because when the triangles are congruent, they are also similar. So, example 2. Next example we are looking at, we want to determine, is triangle RED similar to triangle HAT? So what we have to do is take a look at the smallest set of sides. So I'm going to set up the ratio here for, I'm going to start with the small one right here, which is 3. So 3 is to, on this triangle, it would be 4.5. As medium side is 5 over here, to medium side over here, which is 6.5. Okay, and you got to be careful because that's a common error that I see sometimes where students are, just because the triangles are drawn this way, they're going to say 3 is to 4.5 as 5 is to 7.5, but that is in fact not true. That's not the way you want to set it up. We have to go small, medium, large. So I'm going to take large side here of 6, and then large side over on this triangle, which is 7.5. And then I'm going to take each of those ratios and use my calculator just to simplify. So 3 divided by 4.5 is going to give me 0.6 repeating, which is 2/3. If I do 5 divided by 6.5, that gives me 0.769. Okay, and this one was 0.6 repeating. So right off the bat right there, I don't actually have to go any further. Just that alone tells me, just because those two sets of sides are not proportional, it doesn't matter if this next set of sides are or aren't. But if I did check it anyway, just to see, and this ratio is actually 4/5, which is 0.8. So none of these actually match. So these triangles are not similar. All right. Now, the one thing that I did here is I want you to notice that when I wrote down these side lengths, if I take 3 and I add 1.5 to it, it gives me 4.5. If I take 5 and I add 1.5 to it, I get 6.5. If I take 6 and I add 1.5, that gives me 7.5. So addition is not an operation that you can use to check for similarity. It has to be the right scale factor, which entails you to either multiply or divide by something in order to obtain those same ratios. All right, moving on to our last example. Okay, so here we go with our nested triangles, the trickiest ones of all. All right. Now, the first rule in similarity and nested triangles, first rule for nested triangles is we don't talk about nested triangles, right? Second rule for nested triangles is to draw them separately. So let's take triangle RAT, RAT, And I am going to, oh, there was a 4 there. I don't know where that went to. I apologize. Put that on your picture. Okay, so I'm going to fill in my side lengths. I'm going to use another color. So I got a 5 here, I got a 4 here, and I've got a 3.5 on this side. And then I need to draw the bigger triangle, okay, which is triangle RPY. Okay, so I'm looking at the big one now at this point, where I need to add these two parts together in order to obtain the length of that side. So this is going to give me 7, and then I have to add here these two, okay, right there. And when I add those two lengths together, that's going to give me a length of 10. And my bottom side here is 8. Okay, so I have to now check to see if I can use these 3 sets of sides to prove similarity. So again, we're going small side to small side. So if I go small side to small side, this triangle I'm doing 3.5 is to 7. Oh, that looks nice, because I know if I double 3.5, that's going to give me 7. So I know that's going to reduce to 1/2. I can take my middle side, which is 4, and my middle side length here is 8, and that also is going to give me 1/2. And then I'm going to take large to large, which is 5/10. Okay, my next set of side lengths here. So that's going to give me 1/2. So absolutely, these triangles are similar. So when I write the similarity statement, I need to make sure if I say triangle RAT, so I traced large, then medium, okay, to get those vertices or those angles. And then I have to trace large to medium. So over here, I'm going large to medium. So that way I would have to say similar to triangle RYP by triple side. So, hope you enjoyed the lesson. I'll be talking to you soon.